Welcome back. Today we're going to talk about multiplying polynomials, and we're going to look at 4 different ways that we can do this. So the first method that we're going to talk about is distributive property, but before we get there, I'd like to just remind everybody that when we are multiplying, like bases, we add exponents. Those are the exponent rules that we memorized. And then we always write our answer in standard form. So when we're multiplying using the distributive property, and we start over on our left side with our first term, x times x. Remember, that's x to the first and x to the first. That's x squared. X times 5, positive 5x. We come to our second term. 2 times x is 2x, and 2 times 5 is 10. Combine our like terms. Our like terms are going to be this x to the first and x to the first. So we bring down our x squared. 5 plus 2 is 7x, and we bring down that plus 10. Second power, first power constant, so this is in standard form. I have no other like terms, and so this is my final answer. Letter B. X times x is x squared. X times negative 4 is negative 4x. Positive 3 times x is positive 3x. I'm going to go ahead and write that under its like term. And then positive 3 times negative 4 is negative 12. Bring down our x squared. Negative 4x plus 3x is negative 1x. And bring down that minus 12. Second power, first power constant. This is in standard form. And it's just a different way to go ahead and write our multiplication out when we have our terms, so we combine like terms. If you remember Punnett squares from science, genes, dominant genes, recessive genes used kind of like something that looks like this. We can use this for multiplying as well. It doesn't matter which set of terms you put up on top of the box versus on the side. Just make sure you keep the signs with the value they belong to. And so this means x times 2x, which is 2x squared. X times negative 3 is negative 3x. 5 times 2x is positive 10x. And 5 times negative 3 is negative 15. This is one big plus sign in here. And so that says add your like terms together. Many times, most of the time, your like terms should be diagonal to each other. And so looking at this, I have 2x squared. 10x plus negative 3x is positive 7x. And then we have minus 15. Second power, first power constant. So this is in standard form. I have no other like terms, and we have a good answer there. I try the same method over here with the second one. This time I can put the first term on the left side and the second term on the top. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 3 times x is 3x. And then 3 times negative 3 is negative 9. Again, this is one big plus sign in here. And our like terms are diagonal from each other. 2x squared. 3x plus negative 6x is negative 3x. and we bring down that -9. Second power, first power constant. No other like terms, and this is in standard form. Go ahead and try examples 1 through 4. FOIL. So FOIL is basically a fancy word for distributing, because that's basically what we're doing, is distributing. And the O and the I should be like terms many times, not all the time, because it depends on what you have that you're multiplying. And this is the biggest thing. This only works for a binomial times a binomial. Those first two that we did, the distributing and then the Punnett box method, those works for any kind of multiplying. It doesn't matter if you have a binomial, a trinomial, a trinomial, a trinomial, trinomial, polynomial, anything. But FOIL specifically works for a binomial times a binomial, and that's it. So first, we have x times x. Those are the first terms in our two sets of factors. We have x times x, which is x squared. Outside, the outside terms are x and -6. They're the furthest apart. So x times -6 is -6x. The inside terms are going to be -3 times x, and that's -3x. And then our last terms are a -3 and a -6, which is +18. So when I put these together, here's my middle two terms. They are like terms. So I have x squared, starting at the top, x squared, -3x plus -6x is -9x. And then this last term is a +18, so +18. Second term, first term constant. That's in standard form and a good answer. Example F. Our first terms, 2x times 3x. 2x times 3x. 2 times 3 is 6. X times x is x squared. Our outside, we have 2x times -5. 2x that's -10. 2 times -5 is -10 with the x. Our inside terms are 1 and 3. So 1 times 3x, 1 times 3 is 3 with that x. And then our last terms are 1 and -5. So 1 times -5 is -5. Putting all of this together, our like terms are there in the middle. We have 6x squared. -10x plus 3x is -7x. And then we have -5. Second term, first term constant. This is in standard form and a good answer. You try 5, 6, and 7. And I'm going to do one last set of examples, and this is binomials and trinomials. So I want to talk about one other method, and you can jot this down if you want to. But going way back to like third grade, let's say we had 392 times 46. Well, remember, we'd write it like this vertically and say 6 times 2 is 2, 12, carry the 1, and so on and so forth. And so we're going to rewrite our first example here that same way. I'm going to put my longer term, my trinomial, on the top, and then I'm going to put my binomial x plus 5 on the bottom. And I'm going to say this is multiplying. 5 times negative 2 is negative 10. So the only thing we don't do is we don't do the carrying. 5 times negative 3x is negative 15x. 5 times x squared is 5x squared. Placeholder, because we're done with this. X times negative 2 is negative 2x. X times negative 3x is negative 3x squared. And x times x squared is x to the third. Add our like terms here. We have x to the third, 5x squared plus negative 3x squared is positive 2x squared. Negative 15x plus negative 2x is negative 17x. And we bring down that negative 10. Third power, second power, first power constant. This is in standard form, so that is a good answer. I have to say that probably is one of my more favorite methods for multiplying. I struggle a little bit with foiling sometimes when our polynomials get very large because there are so many things to try to combine. And this kind of lines things up very nicely. I'm going to do example H as one of our Punnett boxes again. Remember, it doesn't matter which direction you go, but I'm going to have my x minus 3 here, my x squared minus 4x minus 4 up on the top. X times x squared is x to the third. X times negative 4x is negative 4x squared. X times negative 4 is negative 4x. Down to the bottom row, negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is positive 12x. And negative 3 times negative 4 is positive 12. Remember that these are a bunch of addition signs in here, so we're combining like terms. Our like terms are diagonal to each other. And so if I were going to write my final answer, I have x to the third. Negative 3x squared plus negative 4x squared is negative 7x squared. 12x plus negative 4x is positive 6x. And then we have a positive 12 at the end. Third power, second power, first power constant. Our answer is in standard form. We will do some more practice with this in class tomorrow. Thanks so much for joining me. Don't forget your U-tries and have a great rest of your day.